Okay, so today we'll start your vectors. Okay, so Kezia, can you tell me that how many types of vectors are there? If you remember,
Ad addition vectors.
okay.
So
What is
what
it?
unit vector? Unit vector.
Okay, so what is a vector, ma?
Vector which is having a quantity which is having direction and magnitude.
Okay, what is a scalar? Can you give some examples for it?
A vector.
Yeah,
Force.
force. Okay, I'll write it down. Force. Then
Momentum.
momentum. Okay, momentum. Then
Torque.
torque. Then okay, velocity. There are so
Velocity.
many things in it. Okay, right now. So vector is nothing but your combination of both magnitude and as well as direction, correct? So okay, let it be. What about the scalar part?
Only magnitude.
Okay, only magnitude. Let's see. Okay. So the chapter name is nothing but your vectors and scalars. So we'll see first of all your vectors splitting part. So we'll see about your vectors. So vectors, it actually it was divided into two types now. Vector, it is actually divided into two types. One was okay, one was your polar vectors, and other one is your scalar vector. That is your axial vectors. One is your polar and one is your axial vectors. Okay, polar vectors and axial vectors. So polar vectors, those which having a starting point, those which having a starting point, okay, which having starting point or any point of application or a point of application, point of application. So let's see some examples about this one. So let's see, for example, so that means assume there is an object. There is an object. It was trying to travel from A point to the B point. When an object was traveling from A point to the B point, that means there is a starting point here and there is a final point. So this is your initial point and this is your final point. When you are applying some force on this object, what will happen? It will try to travel in a straight line. When we are discussing about the straight line motions, we call it as polar types. Okay, polar vector. Okay, examples we'll see. So examples are nothing but your displacement. Okay, so again your velocity, your force, acceleration. So all are your polar types of vectors. Let's see the axial. So axial is nothing but which represent the rotational effect. Which represent the rotational effect. Rotational effect. Okay, so and act along the axis of rotation. And act along the axis of rotation. Axis of rotation. So you can simply say that, so the axial vectors are nothing but you are similar to your rotational motion vectors. So like for example, so here angular velocity, like for example, angular velocity, okay, I'll use the symbols, angular velocity, omega, okay, torque is nothing but your angular force. And after that, we'll discuss about your angular momentum, right? And after that, there are so many things. Like for example, angular momentum, angular acceleration alpha. So these are your few examples for your rotational effect. And one is polar is nothing but your linear, axial is nothing but your rotational effect. So or we can say that polar having starting point. Axial, it doesn't have any starting point. It was starting from one point and it was continuously varying. Without in the same orbit, it will try to continuously varying. There is a rotational effect. There is a constant starting point. So these are the two basic types. In this basic types of vectors, or we can say that this is your division for vectors. So in this division, so the types of vectors has been divided into 11 types. Types of vectors are of 11 types. Types of vectors are of 11 types. I'll give the headings first of all, then I'll explain it. So make the headings. First one, equal vectors. Equal vectors. So we can say the equal vectors are positive vector. Equal vector or positive vector. Second one, so we call it as negative vectors. Negative vector. Negative vector are unequal vectors. We can say unequal vectors. negative vector or unequal vectors. Third one, zero or null vector. Zero or null vector. Fourth one is your unit vector. Fourth one is your unit vector. Fifth one is orthogonal unit vector. Orthogonal unit vector. And the sixth one is your co-initial vector. Co-initial vector. Seventh one, it is collinear vector. Okay. Eighth one, coplanar vector. Okay. So ninth one, it is a localized vector. Okay. 10th one, non-localized vector. 11th one, position vector. Okay, so these are the 11 types of vectors. So basically vector is split into two things. One is your polar and one is axial. So polar is related to your straight line, axial related to your rotational motion. Depends upon these two terms, the vectors has been split. So all are of 11 types. Okay, have you taken it?
1 minute, sir.
Yeah.
Done, sir.
Super. So I'll save it and let's see one by one. Okay. So what is equal vector, if you remember, or what is positive vector? Anything?
Vectors are equal.
Vectors are equal, yes. We can say vectors are equal, but we should not say vectors are equal. So here vectors are equal. That means, so assuming there are two vectors are there, A vector and as well as B vector. Okay, A vector and as well as B vector. So these two vectors are of equal magnitude. Equal magnitude. Equal magnitude and same direction. So when equal magnitude or same direction, when we specify like this, we call it as equal vectors, and those are nothing but same direction. So theta is equal to 0 degrees. So this is nothing but your positive vector. Next one. Next one is your unequal vectors or negative vectors. That means both vectors are traveling in opposite directions. Remember it. Both vectors are traveling in opposite directions. That means the equal magnitude, remember, equal magnitude, but opposite direction. But opposite direction. Third case, zero vector, zero or null vector. So a vector whose magnitude is zero, vector whose magnitude is zero. Magnitude is zero. Okay, so vector whose magnitude is zero. Okay, when we are specifying a zero magnitude, that means there is no specific direction here because there is no magnitude, there is no specific direction. So direction is not defined. Direction is not defined. Direction is not defined. So that is your zero vector or null vector. Let's see some small example. So velocity of a stationary object. Velocity, assume I'm placing an object on the table. So when I'm placing this object on the table, I assume this object is at rest condition. Okay, so when you are discussing about the velocity, here velocity acting on this object when it is at rest condition. So here the velocity is equal to zero because this object is at rest condition. So when even though the time was varying, the object will be at rest condition. That means, so the magnitude of this object is equal to zero. When there is no magnitude, that means there is no direction. This is your third one. A few examples, that's it. Fourth one, we'll see. Fourth one is nothing but your unit vector. Unit vector, so his magnitude is unity. Its magnitude is unity. Magnitude is unity. Magnitude is unity. Okay, so and there is only direction. So it will be identified by direction. defined by only direction. Only direction. So let's see. So the identification, for example, I'm taking a vector. A vector is equal to magnitude and your direction. So A vector equal to its magnitude and direction. If the magnitude is same, so the vector can be identified by only its direction. This is your fifth one. Sorry, fourth one. Let's see fifth one. Fifth one we call this orthogonal unit vector. Orthogonal unit vector, it's nothing but your unit vectors along the direction of axis. Unit vectors along the direction of axis. Here, if you see that there are three axes are there. So x-axis, y-axis, and z-axis. There are three axes: x-axis, y-axis, and z-axis. Okay, so these axes are called as unit vectors. They can be represented as x-axis. It is nothing but your I cap, y-axis is your j cap, and z-axis is nothing but your k cap. So that means when the magnitude is unit, it will be identified its direction by its direction only. Okay, so these are the five types. Just take it one, then we'll see the sixth one. Any doubt?
No, sir. Understood.
Good one. So I'll save it. Okay. Okay, let's see one more. Sixth one. Coinitial vectors. Coinitial vectors means, so when both vectors are starting from common initial points. When both vectors are starting from common initial points, we call it as coinitial vectors. So it has a common initial point here. Both are traveling in different directions, but common initial point we call it as coinitial vectors. Next one. So vectors having equal or unequal magnitudes. Next one is your collinear vectors. Vectors having equal or unequal magnitudes. Equal or unequal magnitudes. Okay, but acting along the same direction or opposite. Acting along same or opposite direction. Okay, equal or unequal magnitude, but the directions are same or in opposite directions. We call it as co-linear vectors. Co-linear vectors. Eighth one, coplanar vectors. Vectors acting in the same plane. Vectors acting in the same plane. Acting in same plane. We call it as coplanar vectors. Ninth one, localized vectors. So earlier we have discussed about the axial point. So when the similar to that axial point only, localized vector, a vector whose initial point is fixed. Vector whose initial point is fixed. Okay, so with respect to the initial fixed points, so when the object was moving, so we call it as localized vectors. 10th one, non-localized vector. So vector whose initial point is not fixed. Whose initial point is not fixed. So this is nothing but your non-localized vector. Okay, now next one, the last one is your position vector. A vector representing a straight line. Remember, a vector representing a straight line, distance and the direction of any point or object. Distance or direction of any point or object. Distance or direction of any point of object. Any point or object. Object, okay, with respect to the origin. Object with respect to the origin. Let's see. So assume these are nothing but your axes. It is your x-axis, it is your y-axis. When you want to find the position of any object or the location, I told you with respect to the coordinates only we can able to find it. So when that object, if you want to identify this position, so we are drawing a straight line from the origin to this object, making a distance assuming it is r. So this vector we call as position vectors. When a line drawn from the position, that is your origin, towards your object, we call it as position vector. Okay, this is your position vector, and these are your types of vectors. Let's take it.
Done, sir.
Okay, super. let's just understand some of the thing. And in vectors, we cannot able to subtract it. So it depends upon the direction only. The multiplication will be the, I mean, direction only. The subtraction and as well as addition will be there. But in vectors, we only add it. We won't subtract it. Okay, let's see. So there are two things are there here. Addition of vectors. Save it and delete it. Next one, addition of vectors. Addition of vector. Okay, so for this addition of vector, there are three methods are there. There are three methods are there. That first one, triangle law of vector addition. Triangle law of vector addition. Second one, we are discussing about the parallelogram law of vector addition. Parallelogram law of vector addition. Okay, and as well as there is one more thing, we call it as your polygon. Polygon law of vector addition. Polygon law of vector addition. Okay, so let's just understand. So triangle method and pure parallelogram both are almost similar. Polygon is a bit different. Okay, let's see. So first of all, we'll try to understand what is your triangle law. So I'm not going to derive it. I'll give the relation. I'll try to explain the concept. Then I'll give the formulas. Okay, let's see. So assume there is a two vectors. There are two vectors. So both magnitude and direction by the sides. Okay, we are mentioning with the sides. So here, assuming this is your triangle method, first one. So assume it is your initial point. So from the initial point, assume there is a vector A. It was starting towards your east. Okay, it was starting towards east. Okay, so with respect to this vector, so there is one more vector which is started. After A, there is one more vector which is started. So I'll take this one as a B vector. Okay, if you see that, so O is your initial point and B is the point which I'm taking it as F. So this is your final point. Okay, so this is nothing but your longest distance to travel from the initial point to the final point. This is your longest distance. For that, what I have to do, I have to find the shortest distance. So the shortest distance is nothing but your resultant. The shortest distance is nothing but your resultant, and this is nothing but your displacement. This is your displacement, and the total is nothing but your distance. Let's see. Now what I'll do, so to make it comfortable, what I'll do, I'll make a right angle here. I'll draw a perpendicular point, from the base axis. So making an angle theta. So if you see that A and B, it was making angle theta. So and any object, B is any object that is here, B is making angle theta with respect to x-axis. We call it as a B cos theta, and perpendicular to it is nothing but your B sin. Okay, now we'll see the relation. So what I'll do, I'll redraw this right angle triangle. So here at the base, A and B both are traveling in the same direction. So when both are traveling in the same direction, we'll add it up. Okay, so here this is nothing but your A plus B cos theta, and opposite direction is nothing but your B sin theta. So this is nothing but your resultant. Remember here to find the direction of the resultant, we are taking an angle. That angle is nothing but your alpha. So resultant. So from this relation, it is nothing but your hypotenuse, Pythagoras theorem. So R is equal to, I'll directly write the final answer. R is equal to square root of, it is A square plus B square plus 2AB cos theta. Okay, this is a final relation when you do the Pythagoras theorem application. So R square is equal to A plus B cos theta whole square plus B sin theta whole square. Okay, when you do the squares, the resultant will be, it is square root of A square plus B square plus 2AB cos theta. And same thing to find the alpha. What I'll do, I'll take tan alpha. Tan alpha is equal to opposite by adjacent. So it is B sin theta by A plus B cos. So these are your relations under triangle. So same thing for your parallelogram also. Same thing for your parallelogram. Parallelogram, that means when two vectors starting from the same initial point. So it is your A vector and it is your B vector. Okay, what I'll do, once A ends, I'll draw the parallel line. So from the origin or from the initial point, so we are taking a positions. That position is nothing but your resultant here. Okay, and as usual, it was making an angle theta. So to make it comfortable and to we can able to solve it. So it is nothing but B making an angle theta with respect to axis. It is nothing but your B cos theta, and perpendicular to it is nothing but your B sin theta. Again, same formulas are there. So here alpha will be your angle between the resultant and one of the shorter distance, shorter path. Okay, so this is your formulas. So both triangle and parallelogram both are having same formulas. Take it.
Done, sir.
Okay. So next one we'll see your polygon law of vector addition. Next one, polygon law of vector addition. So in this polygon law of vector addition, so I assume I'll take pentagon, anything, any sides, more than two, we call it as polygon. So I'll take one line, two, three, four, and five. Okay, so I assume I'm taking a pentagon here. So I assume for this pentagon, so I'm taking an initial point. I'll take an initial point. So this initial point, I'm taking it as A. The corners I'm giving some names. It is A, O, and it is P point, it is Q point, it is R, and it is L. Now let's see that. So it is your initial point, and this is nothing but your final point, making a circular form. Now let's see that. So what I'll do, because O to P, there is a direction here. So when there is a direction, I'll take it as A vector. Okay, I'll take it as direction here, O to P, and P to Q, I'll take it as B vector. It is your C vector, it is your D vector, and it is your E vector. So these are your directions because it was returning back to its again initial point, completing the path. Okay, let's see from the triangle. Okay, I need to travel from O point to the Q point. I need to travel from the O point to Q point. This O to Q is nothing but your distance. O to Q is nothing but your distance. So to find the resultant or to find the shortest path displacement, I'm taking a resultant line here. This is nothing but your resultant. So from this relation, we can say that OQ, okay, OQ vector. Remember, there is a direction from the origin. Okay, OQ vector is equal to, we can say that as OQ vector is equal to, it is OP vector plus PQ vector. It's OP vector plus PQ vector, which is equal to, the vectors are nothing but A vector plus P vector. So if you want to find the resultant, we are going to add it directly. That's it. Okay. Now same thing for the triangle of OQS. Let's see the triangle for OQR. Let's see the triangle for OQ and R. OQ and R. Okay. So OR vector, which is equal to, I can rewrite the relation. See, remember, if you want to find the distances from the O point to the R point, I have to add all the terms. Okay, or we can go with your resultant also some cases. Okay, let's see that. So OR vector, I can write it as your OQ vector plus your QR vector. That means OQ vector is nothing but your R. I'll take this one as R1, I'll take this one as R2. So it is R1 vector plus it is your C vector, where R1 vector is nothing but your A vector plus B vector plus as well as your C vector. So this is your relations. Now same thing, triangle. So here from O to S, let's see from O to S. So O to S, so O to S vector is equal to one complete cycle we have to take. So we can take it as A vector plus B vector plus C vector and as well as the D vector. So O to S, we can say the resultant. I'll take the resultant as R. R is equal to A vector plus B vector plus C vector plus D vector. So we can able to add these two terms. Okay. So this is your polygon law of vector addition. We are going to take only the vector addition itself. So we are not going to consider any angle thetas here. So it is a simple relation because if you see that all angles are making 90 degrees with each other. It has to make 90 degrees with each other. It depends upon the problems, we'll discuss this. Okay. So this is your polygon law of vector addition. Please take it.
Done, sir.
Okay. So let's see some problems in these cases.